Given a set of outcomes, a probability distribution is a way to assign probabilities to individual outcomes. To be a valid probability distribution, it must satisfy the following three properties. It must be true that every assigned probability is less than or equal to 1 and greater than or equal to 0. It must be true that if we sum up the probabilities of all possible outcomes, that the sum is equal to 1. And it must be true that given a subset of all possible outcomes, the probability of that subset is equal to the sum of the elements of that subset. An example of this might be, suppose our subset E contained S1, S2, and some S5, then the probability of that subset, the probability of that event E, is the probability of the outcomes it contains. Some immediate results of these properties are that the probability of the entire set is 1, that the probability of the empty set is 0, the probability of the intersection of two sets is equal to the probability of the first event plus the probability of the second event minus the probability of the union of the two sets. And that the probability of the complement of some event is 1 minus the probability of that event. As an example, let S equal S1, S2, S3, and S4. And let's suppose we were given the following table of probabilities. Our first question might be, what is the probability of S3? To solve this, we would use the fact that the sum of all outcomes should equal 1. This means that 0.2 plus 0.3 plus this unknown probability of S3 plus 0.4 equals 1. So we get that the probability of S3 plus 0.9 equals 1, and that the probability of S3 is equal to 0.1. As a second problem, let's set E to be equal to the set S2 and S3, and let's ask the question, what is the probability of E complement? We'll go over two different ways to approach this problem. First, let's calculate what E complement is. E complement is a set of things not in E, but in our original set S. So we'll conclude it's S1 and S4. So we would get that the probability of E complement is the sum of the probability of S1 and the probability of S4, which is 0.2 plus 0.4, to get the final answer of 0.6. Our second approach is to find the probability of E, which would equal the probability of S2 plus the probability of S3, which we can find to be 0.3 plus 0.1, so 0.4. Then we would use the formula that the probability of E complement is 1 minus the probability of E, which would be 1 minus 0.4, which would also give us our final answer of the probability of E complement being 0.6.